so today is 3.8, and I had to add this in a few years ago, so this is called example 0. And we're going to look at the sine of pi over 3. So we're trying to do this without a calculator, so we're going to look at the unit circle. So on the unit circle, pi over 3 is here. And the terminal point is 1/2 root 3 over 2. So you just have to know that this is the point that goes with pi over 3. And then, of course, the sine is the y value. So that means the sine of pi over 3 is root 3 over 2. Okay, so that's just reviewing the unit circle there. Sine is the y value. So, okay, but then today we're going to look at this, which is sine with the -1 power. And it doesn't mean a power here, it means the inverse. So yesterday we talked about inverses, kind of as an intro to what was going to happen today. And this means the inverse of sine. And the question is going to be inverse sine of 1/2. Okay, so this function inputs an angle and outputs a fraction. So that's what sine does. The input value is an angle, and the output is a fraction. So inverse sine is going to be the flip of that, because that's the way inverses work. So this is inputting a fraction, and it's asking for the angle that goes with that fraction. So we need to find on the unit circle somewhere an angle that has this fraction as its y value. It's not this one, right? Because this one has 1/2 as its x value. Okay, so it turns out that it's down here at root 3 over 2 comma 1/2, which is the pi over 6 angle. So we're asking for what angle has this fraction as its sine value. So the answer is pi over 6. So it's the inverse process. Okay, so this doesn't mean reciprocal. It means inverse, even though it kind of looks like reciprocal. Okay, so keep in mind that if you write sine squared of x, that does mean sine of x squared. But unfortunately, if you write this, it doesn't mean this. So that's a sort of strange decision that was made at some point regarding the notation. It seems like if this means this, then this should mean this, but this is just not true. What is the reciprocal of sine? Cosecant. 1 over sine. This is 1 over sine. This is cosecant. And cosecant is not the same thing as inverse sine. Inverse sine doesn't mean flip the fraction, it means flip the points. So input fraction, output angle, not reciprocal. Okay, so this is easy to mess up because of this weird notation here. And also because it's hard to understand what an inverse is sometimes, because you study inverses and you lose what that means. Okay. All right, so the reason I bring all that up is because we want to do calculus with inverse trig functions today. So we're going to have y equals inverse sine of x. And we want to find the derivative of that. Okay, so as of right now, we don't know how to take the derivative of this. So we need to discover what the formula is for the derivative of this. Okay, so what we're going to do is we're going to rewrite this. This is a fraction, and this is an angle, because inverse sine inputs a fraction and outputs an angle. So that way, I could write this instead. Sine of y equals x. So since this is a fraction and that's an angle, I could take the sine of the angle and get the fraction instead. So the reason I wanted to rewrite this like this is because I know how to do the derivative of this. So now I'm going to take the derivative of it. And it's going to be a disguised chain rule because this is no longer solved for y. So derivative of sine is cosine. Then you plug the regular inside into it. And then you have to finish out the chain rule by multiplying by y prime. So this is what we did in 3.7, the disguised chain rule. Then the derivative of x is 1. And then you divide the cosine to the other side. So y prime is 1 divided by cosine. Now I'd rather not have y in my final answer. So now I'm going to do some algebra to get rid of this y here. Okay, so there's an identity that says sine squared of y plus the cosine squared of y equals 1. So I'm just going off separately. This is separate from this. This is just an identity. Sine squared plus cosine squared equals 1. So then if you subtract this to the other side, that tells you that cosine squared equals 1 minus sine squared. And then if you take the square root, you figure out that cosine is the square root of 1 minus sine squared. And then back here, the sine of y is x. So if I have the sine of y squared, that's x squared. So the cosine of y is the square root of 1 minus x squared. Okay, so then I can replace cosine of y with this, the square root of 1 minus x squared. Yes? I just was using this formula here, just for this problem. It wouldn't always be true, but just for this problem, x is the sine of y. And so I could replace the sine of y with x. Good, yeah. Okay, so I was trying to find the derivative of inverse sine, because I didn't know what the derivative of inverse sine is. And that's what all this was about. And apparently this is the answer for the derivative of inverse sine. Okay, so we're going to write that down. The inverse sine's derivative is 1 over the square root of 1 minus x squared. And so then I'm also going to tell you what the derivative of inverse cosine is. Derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. So I could go through a similar process that I went through over here to find this formula here, but for this one I wanted to construct it and show you where it came from, but then for this one and for the other ones that we're going to write down, I'm just going to tell you what they are and have you believe me. But at least for this one, I wanted to show you where it came from. So it's kind of similar when we did the regular trig functions. I proved the derivative of sine was cosine, and then all the other ones we just wrote down. So that's what we're going to do today for these as well. So derivative of inverse sine is this, and derivative of inverse cosine is this. And it's kind of nice. It's the same exact formula, except it's negative, right? And remember, for the regular trig functions, the derivative of the cos were negative. Same thing here. The derivative of this co is negative. So even for inverse trig functions, you can figure out what the derivative of the cos are. You can remember that those are negative. Okay, so the next one is inverse tangent. Derivative of inverse tangent is 1 over 1 plus x squared. Then there's 3 more. Derivative of inverse cosecant is negative, because it's a co, negative 1 over the absolute value of x times the square root of x squared minus 1. Then the derivative of inverse secant is positive 1 over the absolute value of x times the square root of x squared minus 1. So again, notice these are identical except one is negative and one is positive. Just like over there with inverse sine and inverse cosine, those are identical except the co is negative. And these are identical except the co is negative. So if you had to guess for inverse cotangent, what do you think it's going to be? It's the same as tangent except negative. So negative 1 over 1 plus x squared. Okay, so now we're going to use these trig derivatives, inverse trig derivatives, in a couple of problems. So here's example 2. We have y equals the inverse cosine of 1 over x. We're going to try to find y prime. Is inverse cosine being multiplied by 1 over x? Kind of looks like it, right? But remember, this is a function. So there's not a multiplication sign here, just like with sine of something. The inverse cosine is acting on the 1 over x. So that means that this is 1 over x sitting inside of cosine. So it's a chain rule. The outside function is inverse cosine. And then 1 over x is plugged into that. So outside function is inverse cosine. Inside function is 1 over x. Okay, so the way the chain rule works is you take the derivative of the outside, which is that over there, negative 1 over the square root of 1 minus blank squared. So there's the derivative of the outside. Then you plug the regular inside into it. So inside function here is 1 over x. So you plug 1 over x into that. And then the third step of the chain rule is you multiply by the derivative of the inside. Inside function is 1 over x, but another way to write that would be x to the negative 1. So I have to take the derivative of that. So that's negative x to the negative 2. So this is a little bit tricky because it's the new fact about inverse trig functions that we just learned mixed up with chain rule. Is everybody okay with this so far? Yeah.
Why is it negative x to the negative 2?
So were you okay with this being the same as that?
Yeah.
Okay, so then when I take the derivative of that, I bring the negative out front. And then I subtract 1 from the exponent. And if you subtract 1 from negative 1, it's negative 2, which if you're not well rested, you might accidentally make it 0. But yeah, you're good? Cool. All right. Is everybody all right with this now? You sure? Okay. Thanks for asking. So then you can rewrite. On a free response problem, this would be okay for a final answer. But I'm going to simplify this a little bit just to practice some algebra. But don't forget that on free response, you don't have to go any further than this. All right, so what I want to do first is rewrite this. So this is negative 1 over the square root of 1 minus. Well, I'll square this as well. 1 squared is 1, and x squared is x squared. And then this is negative 1 over x squared. I rewrite that. Okay, then this is kind of strange. I'm going to rewrite this as the square root of x to the 4th. So I'll multiply across the tops. 1 over square root of 1 minus 1 over x squared times the square root of x to the 4th. If you take the square root of x to the 4th, that is x squared. So you can believe me that it's okay to write this. What's a little bit strange is why I would want to do that. So does everybody first believe me that this is true? That that's the same as that. Okay, now the reason I wanted to do that is I'm trying to get rid of this double fraction down here. So I needed a square root so that I could multiply the square root times the square root. This is a regular number. It doesn't have a square root around it. So I can't multiply it inside this square root. But if I turn this into a square root, then with both square roots, I can multiply them together. Okay, so now I'm going to multiply that x to the 4th inside. But I don't really need the entire x to the 4th. So one more kind of, I'm going to rewrite one more time before I multiply it in. Let's see, this is 1 over the square root of 1 minus 1 over x squared times the square root of x squared times x squared. So all I did there was split x to the 4th into x squared times x squared. So now I'm going to take that x squared and distribute it in here. So I got x squared times 1, that's x squared. And x squared times this is 1. So now this is gone because it distributed in. And then I've got the square root of x squared here. This one's still there. Okay, now let's talk about this a little bit. If x is 3, what's the square root of 3 squared? 3, right? Because 3 squared is 9, square root of 9 is 3. Okay, how about if it's negative 3? Still 3, right? Because negative 3 squared is positive 9, and then the square root of positive 9 is 3. Okay, so the point I'm trying to make is, if you start with a positive number and square root and square, you end up with the same number. But if you start with a negative number and square root and square root, square and square root, then you end up with not the same number that you started with. We started with negative 3 and we ended up with positive 3. Okay, so that means that the square root of x squared is the absolute value of x. It seems like the square and the square root should cross out, but that doesn't happen in the negative case. They cross out, but the negative goes away as well. So I need some way of indicating that the negative is going to go away. Well, absolute value is an indication of that. So this is my final answer for my derivative. Now Brandon's noticing something. Brandon, what are you noticing? That this is the derivative of inverse secant. He was noticing that this matches up with that final answer that I got. So why would the derivative of inverse cosine of 1 over x be the same thing as the derivative of inverse secant? Well, the reason why is this fraction here, remember this input's a fraction, this fraction here is the reciprocal of the cosine fraction. So if I've got the reciprocal of the x, then it's the reciprocal inverse fraction. So this is actually the same thing as that, because I flipped the fraction. So that's why they came out to the same derivative. So that's another reason why I didn't stop here, because I wanted to make that connection between inverse secant and inverse cosine. Okay. Let's try. So this is example 3. We got y equals inverse secant of x, and we're going to find an equation for the tangent line at x equals 2. Okay, so for an equation of a tangent line, what's the final product going to look like? Y equals mx plus b, right? Because if you're looking for an equation of a line, that's what it needs to look like. Okay, so this is where we're shooting for. Just the equation of a line. If we are going to write the equation of the line, we need the slope of the line. And this line happens to be the tangent line. So how are we going to find the slope of the tangent line? Take the derivative, right? So first thing we need to do is take the derivative of this. So the derivative of this is, oh, we just wrote it down, it's sitting over there. So it's 1 over absolute value of x times the square root of x squared minus 1. And so this is a formula that'll tell me the slope of this graph at any number. This is the derivative, which tells me the slopes of this. So if I want to know the slope at 2, I just need to plug a 2 into this formula. Okay, so let's see, 2 squared is 4, minus 1 is 3. So this is the square root of 3. And of course the absolute value of 2 is just 2. So this is 1 over 2 times the square root of 3. So this is the slope that I'm going to use in here for m. So now I've got y equals 1 over 2 square root of 3x plus b. Okay, so now the last thing I have to do is figure out what the y-intercept is. So to figure out what the y-intercept is, I need a point on the graph. I know the x value of the point, but I have to plug that into here to figure out the y value of the point. Okay, so I know it's 2 comma something, but I'm looking for the something. So to find the something, I need to take the inverse secant of 2. Okay, so my final answer here, remember inverse secant inputs a fraction and outputs an angle. So I'm looking for the angle that has this secant. Okay, so the secant is 2. Secant is reciprocal of cosine, right? So if the secant is 2, that means the cosine is a half. So the same question would be y equals the angle that has a cosine of a half. So this is saying the fraction is 2, the secant fraction is 2, but that's the same thing as saying the cosine fraction is a half. So I'm looking for the angle that has a cosine of a half. So then on the unit circle, that means my x value needs to be a half. If the cosine is a half, that means on the unit circle, the x value is a half. So then just for memory's sake, what is this number, the y value? Root 3 over 2, right? And then it's easy to remember that this is either pi over 6 or pi over 3, right? But you get mixed up which one is which. So which one is this one? Is it pi over 6 or is it pi over 3? It's pi over 3. Good. Okay, so that means that the answer to this question, the angle that has a cosine of a half, aka the angle that has a secant of 2, is pi over 3. So this answer is pi over 3, which makes the output value on this graph pi over 3. Yes? Yes, so we have to decide what the output of inverse secant is going to be. And the output of inverse secant is always 0 to pi. So what Krista is saying is that down here is 1/2 negative root 3 over 2, right? So the the cosine of this angle is also a half, and that's negative pi over 6. Or sorry, negative pi over 3. So you're exactly right. If I say out loud, what is the angle that has a cosine of a half? This is an answer as well. But to avoid confusion, somebody decided at some point that this symbol was going to mean give me the answer between 0 and pi. And so that's how I knew to pick that one instead of this one. Okay, so what I'm saying is that they, whoever they are, have decided that the range of this is 0 to pi. Just so there's not 2 answers, or 3 answers, or 4, etc. Great, that's a great question. Are you totally digesting that? Yeah. Okay, cool. All right, so now we have the y value, and we can use this x and this y now to figure out this b over here. Okay, so we've got 1 over 2 root 3 times 2 plus b needs to equal pi over 3. So that's kind of nice because the 2's cancel. So then we can subtract the 1 over root 3 to the other side. So b is pi over 3 minus 1 over root 3. All right, so then I got my final answer for my line. It's y equals 1 over 2 root 3x plus that mess, pi over 3 minus 1 over root 3. Is everybody doing okay? This is tough because it's trig, and it's not forwards trig, it's inverse trig, and then it's derivatives on top of that. So that's why it's tough to follow. Are you sure you don't have questions on this stuff so far? Yeah.
I have a question now. This is,
Yeah.
so when the range is 0 to the pi, you're taking like the inverse sine of something, and there's 2 y coordinates, so you just do like...
For inverse sine, it's negative pi over 2 to pi over 2. The range is.
Okay.
Because you don't want, because you're right, for sine, there would be, if we picked this, there would be 2 answers. So they made a different decision for sine,
Okay.
for inverse sine. Good. And for tangent, it's also negative pi over 2 to pi over 2. So that was all mentioned sometime in your math career. But yeah, it was like, it's hard, it's impossible to remember all of that. So that's why it comes up, yeah. And that's why I'm so big on questions, individual questions, because I know if I just say it, the 30 people in the room may or may not remember it this time. But if somebody asks it, now you have a good shot at remembering it for all time. And it just works better. So, yeah.
Did you write the equation for the
Yeah, absolutely. That's why it says find an equation, because I'm saying, hey, I don't care what form it's in. So a totally acceptable answer here would be y minus pi over 3 equals 1 over 2 root 3 x minus 2. Yep. This is totally fine when it says write an equation. And if it's free response. You know, sometimes if it's multiple choice, they went ahead and put it in that form. Maybe they even rationalized this. But, you know, we don't want to go crazy and do too much in one day, so. But yeah, that's a great point that this is a fine answer as well, that Bailey's bringing up. Still good? Okay, we got one more question. Example 4. So y equals x inverse sine of x plus the square root of 1 minus x squared. And we're going to find y prime. Okay, so this part of it is a product rule. Because we got x times inverse sine of x. So you take the derivative of the first thing, that's 1, times regular second thing, plus derivative of the second thing, which used to be over there, right? So it's, I think it's 1 over the square root of 1 minus x squared. Am I remembering that right? That's derivative of inverse sine. Good. Okay, so I got derivative of the first thing times regular second thing plus derivative of the second thing. Now I'm going to multiply by regular first thing. So all of this is the product rule. It's the derivative of that. So now I got to take the derivative of this. And this is a chain rule because it's 1 minus x squared sitting inside the square root. So the outside function is the square root, or the half power. So the derivative of that is 1/2 times blank to the negative 1/2. So I'm doing chain rule on square root, and this is the first step. Derivative of the outside. Then I got to plug the regular inside into it. And then I got to times by the derivative of the inside. I just got the negative 2x by taking 0 minus 2x. Everybody okay with this chain rule being the derivative of that? Okay, so if it's free response, totally fine to leave it like this, but something kind of interesting happens. I mean, I'm not sure you'll find it interesting, but anyway, we're going to go. So we've got inverse sine of x. I'm going to put this over 1, and so then I can multiply the tops, so it's x, and multiply the bottom, so it's square root of 1 minus x squared. So that's that fraction, those two things multiplied together. Okay, then this 1/2 times negative 2x is negative x. So this and this make negative x. And then this is in the denominator because it's a negative power. And it's a square root in the denominator because it's a half power. So it's the square root of the 1 minus x squared. So then something really interesting happens. This and this cross out, right? Because this is the negative of this. So that all equals 0. So the final answer is inverse sine of x. So somebody made up a really cute problem. It wasn't me, I found it in the book, where if you take the derivative of this mess, you end up with this. Everybody doing okay? Thank you for listening.